Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, due to an important project implementation, I'm not able to upload the videos. And yes, from today onwards, you would just receive the videos regularly. And dear friends, today we are here in discussion on imbalanced data, imbalanced classes in machine learning. Yes, dear friends, when working as a data scientist or machine learning scientist, some of the most frequently occurring problem statements are related to classification and mainly binary classification. So because a common problem when solving this problem statement is that a class imbalance. When observation in one classes is higher than the other classes, yes, of course, we just specify it as like an imbalance exists. And here, this is especially this exact problem, why it just making so much huge, or especially in classification problem, this imbalanced data can hamper our model accuracy in big time. So, and it appears in many domains, including fraudulent detections or spam filtering, disease screening, and advertising click throughout. So let me just discuss into this by using codes also. And the most major techniques whichever we use here, yes, here we are just going to have it in a classification problem. Okay, yeah, dear friends, as we are going to have the classification, of course, we are including the model, and here we specify it as a logistic regression. And let I just execute this. And yes, of course, dear friends, still now we have not yet discussed about the metrics. Of course, next session it is all about the metrics, mainly on classification and regression particularly. Yes, we just discuss it in detail. Okay, yes, yeah, dear friends, most machine learning algorithm work best when the number of samples in each classes is about equal. So this is because most algorithms are designed to maximize accuracy and reduce errors. However, if the data frame has some imbalanced classes, then in such case, yeah, you get a pretty high frequency, or high accuracy just by predicting the majority class. Okay, so but you fail to capture the minority class, which is most often that the point of creating the model in the first place. Okay, so yes. Here for an example, if the class distribution shows that 99% of the class has a majority class, then any basic classification model like this logistic regression or decision tree, which we are just going to discuss it both of the thing, will not be able to identify the minority class data points. Okay, so yes, today we are just going to include a credit card data. Okay, and credit card data companies just which have find out whether the credit card transaction was fraudulent or not. So let me just have a view onto this. Yes, of course, it has 32 columns. Okay, and of course most of them are here, it is as v1, v2, v3. So okay, of course we are having totally 32 columns under this. And let me just have the class functionalities. And kindly observe here, dear friends, you can just clearly see that there is a huge difference between this data set. This is 9,000 non-fraudulent transaction and 492 fraudulent transaction has been done. So even you can just have a view on towards what is fraudulent and what is non-fraudulent, and what about the count percentage, where when we just make on towards the target, or even you can just have a view onto this. Kindly just see here. So most probably see when you have towards this transaction, only 6% of transaction here are fraudulent. Now before even we start, you are able to see how this problem might happens. Okay, so imagine if you don't bother training a model at all. Instead, what if you just write in a single line just what is the prediction? Of course it just say no fraudulent, because of course we are having an highest data which is trained here, it is as like non-fraudulent. Okay, so unfortunately the accuracy is misleading, and for all those non-fraudulent transaction you would have 100% accuracy, and for those transaction which is fraudulent, of course you have zero accuracy, and here your overall accuracy would be high simply because of this transaction or not fraudulent. Because of course here we are not discussing about that model, whether the exact machine learning model is good or not. Okay, so this is clearly a problem because many machine learning algorithms are designed to maximize overall accuracy. Okay, and here in this session we are discussing about the imbalancing the data. Okay, yes, let me just have a view as towards whether there is any null values is there or not. And dear friends, we are not much more dependent on towards this data analysis here. Okay, and even though if you just want to have a correlation map, kindly just have a view how it just shows. Okay, a few correlations and positive correlations, negative correlations are all able to see here, but we are today in discussion about that imbalancing part. Okay, and when on exactly receiving on towards the respond towards the target value, kindly just observe we are just making it towards the just x and y value. Okay, and yes, it is obviously specified as I have already specified 492 fraudulent and 9000 it is non-fraudulent. Before going on to the model application, of course, we all know I have already specified in our machine learning introduction. Yes, dear friend, before fitting in towards the model, you have to split the data into training and testing data. And clearly, kindly just observe, dear friends, this test data size here I specified 0.2. Yes, it seems to be as like training data, it is 80%, and testing data, it is 20%. And of course, even now I want to specify one specific important point is, dear friend, even if you just want to have an learning or a comparative study, kindly just change the size and observe the performance about the model accuracy also. Okay, you can learn a lot. Okay, now moving on to the model. Yes, dear friend, yeah, in machine learning, yeah, we have three categories as like supervised, unsupervised and reinforcement. And under supervised there are two main things is classification and regression. And coming towards here, yes, dear friends, this regression part, yes, of course, I just missed an S here. I include a logistic regression. Yes, this exact logistic regression is a classification model, and don't get confusion. We are just going to discuss why this logistic regression is the named regression thing is comes under classification model. That is also we would discuss further. And before going on to the once on creating the model, I am just going to fit in towards for prediction. And kindly observe that 98.8%. And what would be the unique? Of course, here we are able to understand that mainly one major issues whenever a new developer users fall into when dealing with this unbalanced data relates to evaluation metrics that is used to evaluate their machine learning model. And using simpler metrics like accuracy score can be misleading. So in a data set with highly unbalanced classes, the classifier will always predict the most common class without performing any analysis of the future, and it will have a high accuracy rate, obviously not the correct one. Okay, so here let me just give some more classifier models, and then we just have a detailed discussion. Okay, one such a highly used is XGBoost. Yes, it comes under ensembling technique. Okay, and here we are just, so if you are not able to install, kindly just install it and then import the data. Okay, so here it is a simple XGB classifier. and kindly just have, we are including this and fitting into the training data of x and y, and here x is the main classes and y is the target. Okay, and here we are predicting with the x test data, and when on just observing the accuracy, yes dear friends, this accuracy score, ROC, F1 score, everything we are just going to discuss it tomorrow. Okay, in the tomorrow's next session. Okay, and kindly just observe here dear friends, we can see 99% accuracy. We are getting very high accuracy because it is predicting mostly the majority class, that is non-fraudulent. That is what here it is specified. Okay, now even if you want to make it in much more functionality on confusion matrix also, yes, we are able to see that yes, it comes under the majority class, that is non-fraudulent, which is 0, 1. Okay, now what is the main technique? Dear friends, we are just going to apply a resampling technique to solve this class imbalancing. That's to mainly binary classes, that is binary classification. See, one of the widely adopted class imbalance technique for dealing with highly unbalanced data set is called resampling, and it consists of removing samples from the majority class, which is simply specified as like undersampling. And if we are adding more examples for the minority classes, it is specified as like a oversampling. Okay, now let me just have what is an technique here. So for that, I just want to create a class counts. So that is what is the zero size. That is, kindly observe, we have that is shape as like 9,000 into 32 futures and 492 with the 32 futures. So this is what the class 0 and class 1 functionality. So let me just go on to the first technique as undersampling. Okay, so this is what undersampling. Okay, the image is very high and I just want to specify it. Let I just open into a new tab so that you can just see. Okay, this is what and undersampling. Okay, so kindly just see here dear friends, this undersampling can be defined as removing some observation. So removing some observation of the majority class. So here class A has the majority class. Okay, so removing some majority, this is done until the minority classes is balanced out. So class B is the minority, I just want to balance it. And here undersampling can be a good choice when you have a ton of data, that is think millions of rows. But a drawback to undersampling is that we are removing information that may be valuable. Okay, yes. And yes dear friends, in undersampling, the simplest technique that involves removing random records from the majority classes, so which can cause, as I have already specified, loss of information. And here when on just implementing that credit card fraudulent example, see we just specify class 0 and class 1. Okay, so that will be considered. And here on undersampling, once after resampling the functionality, I am applying here. Okay, now let me just have it once again. Kindly just observe dear friends, once after resampling, kindly observe, so it is equivalent to the class B. The class B here it is, yes, 492. Now both are the data which it has is 492. So this is what the exact data under sampling. Okay, so here most of the data that has been removed, that maybe loss of information happens. Okay, now moving on to the oversampling. So kindly just have a look. This is what the oversampling. And dear friends, despite the advantages of balancing classes, that this exact techniques also have their weakness, that is there is no free hand. Okay, one thing, oversampling can be defined as adding more copies of minority. Okay, adding more copies of this minority. So minority is class A. So if I just make a copy of this, we just have the oversampling functionality. So oversampling in machine learning can be a good choice when you don't have a ton of data to work with. If you want, yeah, you can have a copy of it. And account to consider when undersampling is that it can cause overfitting and poor generalization to your tested data set. Okay, yes. Now let I just apply this oversampling here, and kindly just observe class 1 over, and here I'm just making it and observe to that both now it has 9,000 records. So class 1 and class 2. Yes, dear friends, we have so many technique to balance data, and let me just have one important Python module, that is Imbalanced Learn module. And yes, a number of more sophisticated resampling techniques has been proposed in the scientific literature. And yes, for example, if we just if we can cluster the records of the majority class and do the undersampling by removing records from each other, or thus seeking to preserve information, and here in oversampling, instead of creating exact copies of minority class records, we can introduce small variation in those copies, creating more diverse synthetic samples. Okay, so let me just use some of these resampling techniques using this Python library, that is Imbalanced Learn, and here also I'm just installing it and importing it. Okay, so here let I just import that, and yeah, so you have already done it, and this is also another library, okay, so which is used to sample imbalanced data and improve your model performance. Okay, and let me just make use of random undersampler. Dear friends, random undersampler is a fast and easy way to balance the data by randomly selecting subset of data for the targeted class. And here undersample the majority classes by randomly picking samples with or without replacement. So that is what here we just specify the replacement. Kindly just observe whether with or without replacement. And here, yes, replacement, it is specified as like true, and observe the original data and with the counter, and once after resample data, what you receive is, yes, 492 in 0th class and 492 in the class 1. And next one, using Imbalanced. Okay, Imbalanced, yes, one way to fight imbalanced data is to generate new samples in the majority classes. So the most native strategy is to generate new samples by random sampling with the replacement of currently available samples. Okay, so that is also here we are just making on to random over samples, and it just going to provide what is the original data set, and once after resampling we receive here, kindly observe, yes dear friends, so both are here as 9,000 records, that is 9,000, fine. Okay, and next one more technique, an important technique. So here it is tomplings. So this tomplings are pairs of very close instant but of opposite class. Kindly just observe, these are close but both are opposite. And kindly observe dear friends, this one we are under binary classification. Okay, and removing that instance of the majority class of each pair increases the space between these two classes, so facilitating the classification process. And yes, tompling lengths exist if the two samples are the nearest neighbor of each other. Okay, so let me just go with the code here, and let me apply. Okay, so for this, of course, we have to import this under this library Imbalanced. We are making use of undersampling with the Tomkins. So what is undersampling? So kindly just have a note of it. Undersampling, we are still making it with the nearest one. We are just going to remove it. Okay, so kindly once after making it, I just want to specify with a sample strategy as like majority. Okay, and once on, so yes, so kindly just I scroll down. So here we have, so this is what our data of 0, and yes, class 1 here still it is 492, and what happens, yes, still more it is in unbalanced only. And the next technique which we are here using is synthetic minority oversampling technique. Synthetic minority oversampling technique. This technique generate synthetic data of the minority, and kindly observe here this blue color it is of majority and green it is of minority, and here we get a synthetic data of this minority that is generated, and yeah, once on resample we just get a equalized somewhat. So here, dear friends, SMOT, that is what the shortest form of synthetic minority oversampling technique, okay, which works by randomly picking a point from the minority class and compute the k nearest neighbor for this point, and the synthetic point are added between the chosen point and their neighbor. Kindly just observe here. Okay, and yes, when on just including towards the code, kindly just observe, dear friends, here we work with four simple steps. Okay, so choosing the minority, okay, and finding the k nearest functionality, and choose one of these neighbor and place a synthetic point anywhere on the line joining towards the function. So it is going to repeat it until the data is balanced. That is what happened towards this, and that is the exact behind this algorithm, okay, this function. So let we have and observe, dear friends. So this is how we have. Superb. So both are here in 9000. Okay, yes. And next, one more technique we have, it is near miss. Near miss, actually it is an undersampling technique. Instead of resampling the minority class, using a distance will make the majority class equal to the minority classes. And yes, dear friend, here what we are just going to do is, so here this green, it is what the minority. I just want to make it equal, and we are going to remove this which is far away. Okay, so towards the majority class equal to the minority class, we are, instead of resampling, we are just going to have only with the distance functionalities. Okay, so let we just apply that and observe the data. Yes. So here we are able to see that is original data which we just have class 0 as 9000 and class 1 as 492, and once after resampling here we just have both the things as 492. And rather just using all this technique, we can also perform some more evaluation functionalities. That is, see, actually mainly when on just performing this evaluation metric, there are so many things that are under classification. Okay, and accuracy is not the best metrics to use when evaluating imbalanced data set, as it can be misleading, which I have just already specified. Okay, so that other than accuracy, what are all the things we can just make use of? Yes, here ROC AUC, that is actually what we just say, that is the area under ROC curve. So which represents the likelihood of your model distinguishes observation from two classes. In other words, if I randomly select one observation from each class, what's the probability that your model will be able to rank them correctly? So that comes here in ROC AUC. And when coming towards this F1 score, yes, the weighted average of this precision and recall. So precision is the number of true positive that divides by all positive prediction, and when coming towards the recall, the number of true positive divided by the number of positive values in the test data. Okay, yes, we are just going to discuss this evaluation performance evaluation metrics in the next session, but anyhow, let I just make use of the same XGB classifier. Okay, and let we apply here towards this ROC accuracy and F1 score, and kindly observe here, dear friends. Okay, so yes, dear friends, you are able to apply this, and I just scroll a little above. So when on making use of this XG boost, 1 second, so kindly observe here this accuracy, we just have 99, okay, and ROC it is 99, and F1 score it is 91. And what happened to now? The ones after this, so ROC it is reduced to 94.9, that is 95%, and accuracy also 95, and increasing the F1 score, that is the weighted average of this precision and recall. So yes, dear friends, there is a change. The changing the performance metrics also would just give you one among the balancing functionalities. And next towards this, there is another part of it is penalizing algorithm, which comes under cost sensitive training. Dear friends, actually this exact algorithm is actually that increases the cost of classification mistakes in the minority classes. So actually this one is a popular algorithm for this techniques, which we just make use mainly on SVM, that is a support vector machine, that exact algorithm. And during training we can use the argument which we just specify class weight that should be in balanced to penalize mistakes on the minority class by the amount proportional to how underrepresented it is. Okay, and we also want to include that argument probability is equal to true if we want to enable probability estimations to this SVM algorithm. And let's train the model by using this penalized SVM on this original imbalanced data. Okay, so here let me just have a view onto it, and once on able to see. So once again, dear friends, let me just train the model and let me observe the output. Okay, so observe here, the accuracy is 46.7. How a drastic change is there. And here ROC AUC here it is 60.9, that is 61% only. Okay, so there are so many things are there. And yes, as I have already specified, one particular concept that you can also change the algorithm and check for the accuracy. And in one such a case, we can just go towards a tree-based algorithm. And dear friends, while in every machine learning problem, it is a good rule of thumb to try a variety algorithm. It can be easily mainly especially beneficial with imbalanced data set. Okay, and here a decision tree frequently perform well on imbalanced data. So in modern machine learning tree ensemble, as like random forest or gradient boosted trees, there are so many things are there. Almost always outperformance, that singular decision tree. So we will just jump into that random forest classifier. And yes, dear friends, here tree-based algorithm work by learning a hierarchy of whether class A or class B, like that, if and else questions. Okay, and this can force both classes to be addressed. Okay, and yes, let me just have its accuracy and observe. Yes, we just got a good accuracy. Yeah, it is, seems to be 99%, and when coming towards this ROC, it is 91. Dear friend, when on just discussing all these techniques, really kindly just observe, there are so many techniques, not only these simple things. You can just combine any of the particular things. Okay, and it is likely to have so many observation towards classes and towards the techniques. And yes, we have seen various techniques to handle the class imbalance in a data set, but there are actually many methods is there to try when dealing with this. And yes, and in such a case, this would be very much important, mainly on when you just make use of this machine learning algorithm, that is to imbalance. Yeah, there are about to undersampling and oversampling. That's what's that, and that difference we have just discussed. And this difference between oversampling and undersampling tells you about the how imbalanced classification is performing in machine learning. And with the difference only of undersampling and oversampling, you will come to know also how imbalanced classification is important and how it's performing these. And there are so many advantages. Of course, if you just specify advantages and disadvantages, separate advantages and disadvantages are there under oversampling and undersampling also. Okay, and yes, dear friends, when you just take on towards methods, yes, most widely used technique here, it is SMOT. Which we just say that is yes, a synthetic minority. Okay, so synthetic minority, that is what mostly used techniques. And there is no best method for handling imbalance, because it is depends on your use cases. It is depends on your objective and mainly what the project, what the data you are using it on. Okay, so yes, I hope I have just given you a good input related to how to handle it and various methods we have discussed, and hope this would be an informative for you. And if it is very informative, kindly just put a like and kindly share to the needy ones, and see you in another video, dear friends, and happy learning.